Today, lesson 36C, Properties of Exponents. Today we put together all of the different ideas that we have been talking about lately. The last two lessons we dealt with zero as an exponent and negative exponents. And today we're going to talk about something that all of you already know, that I know that all of you already discovered on your own. The only problem is utilizing those strategies with negative exponents. There are many more mistakes made because of people not totally paying attention to what they do. So today, make sure that that does not happen to you. So my first question is this, and you're going to have a very quick conversation with your shoulder partner. And the question is, have you noticed a pattern when multiplying two expressions with the same base with regards to exponents? Quick conversation with your shoulder partner. 10 seconds, go. Sure. All right. Overwhelmingly, I heard that you do what with the exponents? Let's try that again. Do what with the exponents? You add them, exactly. And we started these by expanding or extending the product so that you could see that that really is what's happening. So here we clearly have 5 fours. And we could have gotten there a lot faster by adding the two exponents. And that's what we do when the base is the same and we are multiplying the expression. So 4 to the 5th power. And my hope that today is that we can start jumping straight to getting there this direction. Unless you're asked to expand or extend the product. Same thing in the next one. We have 7 to the 4th times 7 to the 4th. Well, the fastest way of getting there is utilizing that property. 7 to the 4 plus 4, and that is 7 to the 8th power. Next question. Well, we got to fill in some blank areas first here. When multiplying like bases, keep the base the same and add the exponents. When multiplying like bases, keep the base the same and add the exponents. Now let's go to that second idea. Have you noticed a pattern when dividing two expressions with the same base with regards to the exponents? Quick 10-second conversation with your shoulder partner. All right, so once again, overwhelmingly I heard subtract the exponent. So it'll be the numerator exponent, subtract from that the denominator exponent. And so we did this by expanding or extending the product, and we got to 5 to the 2nd, but now we can utilize this property, 5 to the 6 minus 4, and that is 5 to the 2nd. Same idea with the bottom problem here. We're going to have negative 2 in parentheses to the 4 minus 3 power, which is negative 2 in parentheses to the first. And so, more blank areas to fill in here. When dividing like bases, keep the base the same and subtract the denominator exponent from the numerator exponent, which is another way of saying numerator exponents minus the denominator exponent. And then the third idea that we have talked about is this. Have you noticed a pattern when having a power to a power with regards to the exponents? 10-second conversation with your shoulder partner. So, look, you guys had already realized these on your own. And that's kind of what I said from the very beginning, that you would recognize these patterns within exponents. So in this one, extending the product or expanding the product, we can see we have 8 threes, but now we can utilize this property, 3 to the 2 minus 4 power, which is 3 to the 2 minus 2, 3 to the 2 times 4, which is 3 to the 8th. And then in the second one, 7 to the 3rd times 3, that is 7 to the 9th power. Okay, now that's with positive exponents, but it wouldn't be a rule unless we could then apply that to negative exponents. So fill in some blank areas here. When raising a base with a power to another power, keep the base the same and multiply the exponents. All right, so now transitioning to negative exponents. Here we have two multiplication problems. The bases are the same, so therefore we add the exponents. Now the only thing you have to pay attention to is if you end up with a base to a negative exponent, we have to go one more step because typically in math, we're not allowed to leave things with negative exponents. Okay? So, in the first problem, that ends up becoming 2 to what power? Let's try that again. 2 to what power? Second. Some of you are like you're not sure, like you've forgotten how to add 4 plus negative 2. 4 plus negative 2 is 2, and so we do end up with 2 to the second power. Now, let's talk for a second about what kind of work I expect to see today. If you are given a problem like this, this is what I expect to see. This as your work, and this as your answer in exponential form. All of this stuff in here is the way we did it last week. We're not worried about that right now. We're jumping to the properties. So I need to see this, and I need to see in exponential form. Okay? Could I get all of you to try the next problem? So in the second problem, we have a multiplication problem where the bases are the same. So therefore, we may add the exponents. Now I'm doing all the extending of the product right there. We want to jump straight to here, though. So I need to see this as your work, and then of course 4 to the negative 5, but that is 1 over 4 to the 5th. So I need to see this, need to see that. And make sure that that is very clear, bless you. Now division. And I'm going to tell you right now, it's not the power to a power problems that worry me or the multiplication problems that worry me. It is the division problems that worry me because from experience, when there are negative exponents, one or both of them, and we have a division problem, this is where mistakes tend to happen. Everybody try this based on what you know. So the long way of getting there is by extending or expanding the product like we've done before. And we should get 1 over 7 to the third. But the faster way is by subtracting the exponents because we have the same base and we have a division problem. And so that's what I expect to see for your work right there. 7 to the negative 9 minus negative 6. Numerator exponent minus denominator exponent. Well, negative 9 minus negative 6 is 7 to the negative 3, or leads us to 7 to the negative third, and that is 1 over 7 to the third. Okay? Now, power to a power, based on what you know. Go ahead and try that one. And that one should have taken all of about 2 seconds. Right? What is it? 6 to the 6th power. The long way of getting there, which is the way that we did these last week, the faster way is utilizing that property. Multiply the exponents. Negative 2 times negative 3 is 6. So we have 6 to the 6th power. Now, one last thing before I have you try a block of problems, and that would be this. What happens if the bases are not the same? Well, the properties we've talked about, every single one, it started with this. When multiplying like bases, when dividing like bases, when raising a base with a power to a power. Here we do not have like bases. We can't make up rules that don't exist. So therefore, if I expand the product, you should see there's nothing I can do. And so you don't make up rules that don't exist. So in other words, what I'm saying is don't do this. There's nothing we can do here because the bases are different. Same thing in the next problem. The bases are different. If we extend or expand the product, we have no like factors here, so we just have to leave it alone. Yes?
For 4q times 2 squared, it could be 4 to the 4th.
What is 4 to the 4th? Because you're turning 2 squared into 4, which is 4 to the 1st. Yeah, if we were asked to do that, then yeah, we could do that in that one. All right, so don't make up rules that don't exist. All right, basic exponent rules. 0 as an exponent. We've talked about that in full detail. We've talked about negative exponents in full detail. And now we've added these three properties: multiplying with exponents, dividing with exponents, and power to a power with exponents. All right, could I get everybody to do 1 through 6? We're not going to evaluate anything today. We're simply going to write our answers in simplest exponential form with positive exponents. It says show all steps. I've already talked about what I need to see as far as steps go. I'll get back to you in about a minute and a half. So number 1, we have a multiplication problem with like bases, so therefore we add exponents. I need to see that step right there in every single problem. That is 5 to the negative 1, which is 1 over 5. Number 2, we have like bases and in a division problem. Therefore, we subtract exponents. I need to see that step right there in every single problem. That, of course, is 7 to the 4th. Number 3, we have another multiplication problem with like bases. Therefore, we add exponents. Negative 7 plus negative 7 is negative 14. We need a positive exponential answer, though. Therefore, it should be 1 over 6 to the 14th. Number 4, when we have a power to a power, we multiply exponents. Negative 4 times 4, and once again, I need to see that step right there. That leads us to 3 to the negative 16th power, which is 1 over 3 to the 16th. Number 5, add exponents because we have like bases in a multiplication problem. I need to see that step, and that leads us to 2 to the 2nd power. And number 6, this is when both, in a division problem where both exponents are negative, these are the ones that people tend to make mistakes on. But if you clearly show that step right there, there shouldn't be any issues, right? We started the year with doing problems like negative 5 minus negative 7, which happens to be positive 2, by the way, so that's 5 to the 2nd power. All right, do the next block of 6. This should go a little bit faster now. I'll get back to you in about a minute and a half, and we'll compare with our shoulder partner. Next block of 6, please. Here we go. Number 7 is a division problem with like bases. Therefore, we subtract the exponents. Make sure that you show that step. 6 minus negative 6 is 12, so we have 7 to the 12th power. Number 8, when we have a power to a power, we multiply exponents. Negative 4 times negative 2 is 8. That one gives us 4 to the 8th. Number 9, when we have a division problem with like bases, we subtract exponents. Don't forget to show that step. Negative 4 minus 4 is negative 8. Therefore, we have 3 to the negative 8, but we've got to go one more step. We end up with 1 over 3 to the 8th. Number 10, another division problem. Therefore, subtract exponents. 9 minus negative 9 is 18, so we end up with 8 to the 18th power. Number 11, a multiplication problem with like bases. Therefore, we add exponents. Negative 6 plus 8 is 2, so we have 4 to the 2nd. And number 12, a power to a power. Multiply exponents. Make sure we have our final answer with positive exponents. So therefore, 1 over 9 to the 16th. So far, this should seem pretty easy. Now we're going to take it up a notch. What if we have more bases? Well, all we have to do is follow the order of operations. And one of the things that gets lost when you learn the order of operations would be order of operations within a fraction, which is really what we have here. So if you have a fraction, which in both of these we do, we should simplify the numerator if we can, and then we should look at the denominator and simplify the denominator if we can. Well, in number 13, I can't really do any simplifying with the numerator, but the denominator I can. What does the denominator become when you simplify that? 2 to the what? 2 to the 8th power, okay? And so now I have this. Now it's just like all the other problems that we did, and we would end up with 2 to the negative 4, and that is 1 over 2 to the 4th. Now I realize some of you, because you're used to the other types of problems we did last week where we were trying to find common factors, some of you might have noticed something that you can do here and here. I mean, if you see that from the very beginning, that's fine with me. I'm not going to talk about that, but if you see that, it's okay. So number 14, if I can simplify in the numerator, I should do that, and I can. Denominator, I can't do anything, but numerator, 4 to the negative 5 times 4 to the 8th is 4 to the 3rd. And I'm showing you why it's 4 to the 3rd. So now you end up with 4 to the 3rd over 4 to the 3rd. Well, you should recognize the fact that that's 1. If you didn't, you could have subtracted the exponents and gotten to 4 to the 0 power. But regardless, you should still end up with 1. Okay? All right. Back side of your notes, everybody do number 15 and number 16. We're going to do it in blocks of 2 now. Do number 15 and number 16. So as I mentioned earlier, all we are really doing here is following the order of operations. And within this problem, we have parentheses. We should simplify as far as we can within parentheses. That's not the only way of doing it, but we're less likely to make mistakes if we do follow the order of operations. So what I'm saying is we should simplify this as far as we can, which means we need to simplify the denominator first. Can't do much with the numerator. So the denominator, we add exponents because we have like bases and it's a multiplication problem. So that turns into 6 to the 4th over 6 to the 2nd. Well, we're not finished simplifying within the parentheses yet. 6 to the 4th over 6 to the 2nd is 6 to the 2nd. So now we have 6 to the 2nd to the 2nd. And that, of course, is 6 to the 4th. Number 16, we should simplify the numerator. Well, to simplify the numerator, I've got to figure out that power to a power first. 2 to the 3rd to the 2nd is 2 to the 6th. Now I should finish simplifying the numerator. 2 to the 2nd times 2 to the 6th is 2 to the 8th. And 2 to the 8th over 2 to the 2nd is, of course, 2 to the 6th. Any questions about either one of these? All right, do the next block of 2. Do number 17 and number 18. Number 17, we should simplify the denominator because we can. So we end up with 3 to the 5th over 3 to the 3rd, and that simplifies to 3 to the 2nd. No issues with that problem. Number 18, we should simplify the numerator and then simplify the denominator. The numerator, we have a power to a power. The denominator, we have 2 bases where we're multiplying this like bases, so we have to add the exponents. So here's what we have so far. Everybody okay with that? Yeah, when I walked around, I saw that, but it's from here that we had problems. Because some of you tried to do that in your head, and you say, oh, well, that's easy. That's 3 to the negative 2 power. No, it's not. We don't add exponents when we are dividing. We subtract exponents. So it should be 3 to the 14th power. Okay, so be careful with like bases and division problems where one or both of the exponents are negative. So I want to make myself clear. I need to see steps like this and this because that will alleviate those problems. Okay? All right, we're going to do all 4 of the last ones. Work on them with your shoulder partner. Go through it with your shoulder partner step by step. And I'll get back to you in a couple of minutes. Finish them off. Number 19, we need to simplify the numerator and simplify the denominator. So numerator, we have a power to a power. Denominator, we have like bases in a multiplication problem. So we end up with 5 to the negative 8 over 5 to the 0, which is clearly going to be 5 to the negative 8, which is 1 over 5 to the 8th. Number 20, we only need to simplify with the numerator first. So we have a power to a power and then another power to a power. So we end up with 2 to the 0 times 2 to the 6th over 2 to the 2nd. Obviously, the 2 to the 0 power doesn't affect anything because it's 1. And so we end up with 2 to the 6th over 2 to the 2nd, which is 2 to the 4th power. When I walked around, everything seemed to be pretty good at that point. Number 21. I had to make sure that I threw one in where the bases were all different. And when the bases are all different, you can't do any simplifying, especially when there are no factors in common. And there aren't in this problem. So bases are not the same, no factors in common, no common factors. Number 22, we should follow the order of operations. Simplify as far as we can within the parentheses. So we need to simplify the numerator first. So we end up with 7 to the negative 5 over 7 to the negative 3, all of that to the 4th power. Let's keep simplifying within the parentheses. We have a division problem with like bases. Therefore, we subtract the exponents. Don't forget to show that step. Negative 5 minus negative 3 is negative 2. So we have 7 to the negative 2 to the 4th. Power to a power now. We end up with 7 to the negative 8, which of course is 1 over 7 to the 8. All right, we are finished.